Curious tone. When generative video models are pushed to imagine the distant future, they hit a representational wall. Instead of high-tech cities, they repeatedly output a lone figure on a desolate beach, staring at a half-buried shipwreck. This happens because these systems lack a functional concept of time. When the predictive math runs dry, because it cannot resolve the request for true novelty. These specific failure modes suggest a broader structural reality. The training data that builds these systems also defines the limits of their survival. When pushed beyond those limits, the collapse follows the exact contours of the original design. This visual glitch is a symptom of a wider crisis in artificial intelligence, the interpretability problem. We are increasingly reliant on systems whose internal decision-making is functionally invisible to us. Most modern AI operates through hidden activations and compressed reasoning. We see the data going in and the answer coming out, but the logical steps connecting them stay buried inside the black box. When these systems operate without transparency, they risk creating a sycophant field, a closed loop where human audiences and AI models simply mirror each other's expectations instead of analyzing reality. If we remain inside this automated, unquestioned loop, we lose our ability to steer the technology. We end up following the machine's internal logic because we lack the tools to challenge it. Breaking this loop requires more than just better prompts. It requires a method for intentionally disrupting the machine's predictive rhythm. This is where recursive vector interference, or RVI, comes in. RVI works by forcing multiple, competing reasoning paths to collide inside a single system. This collision prevents the model from taking hallucinated shortcuts or settling on the easiest, most predictable answer. Injecting this structured interference forces a drifting system to stabilize. It uses the tension between different pathways to produce a reliable, verified output. The practical application of this theory is the Cognitive Trace Management System, a software architecture designed to track and verify these internal operations. The CTMS pipeline begins with a thought tree. Instead of a single response, the model generates distinct reasoning paths. During the traverse phase, the system selectively explores these branches. Finally, the flatten tree step compresses the chosen path into an output, leaving a permanent, timestamp trace. This is managed through a control grammar called Neuralese. By using specific operators like seed, fork, and recurse, engineers can manage the flow of reasoning and prevent the model from bypassing its own logical checks. This transforms the AI from an opaque tool into an auditable process, leaving a traceable record for every decision made along the path. This level of forensic detail is necessary because we have seen what happens when foundational research is allowed to slip into the shadows. The San Francisco Art Institute once served as a hub for foundational research into telepresence and networked intelligence. But as the institution's stewardship failed, its public and charitable assets began to wind down. While the physical school withered, the conceptual work it incubated was extracted by private labs and rebranded under different names. This same pattern of extraction is now visible in the way foundational models are being moved from public interest research into proprietary corporate structures. This regime relies on institutional opacity and the capture of charitable assets. It turns shared intellectual property into private capital by ensuring the process remains unrecorded. CTMS is a direct response to this history. It is a compliance engine built to enforce transparency where human institutions have failed. By making every internal decision traceable and logged, we create a direct countermeasure to the corporate black box. It shifts the burden of proof from the user back to the machine. To survive the current technological climate, we have to refuse the promise of effortless, opaque answers. We must demand a system that provides an absolute, public, and causal trace for its reasoning.